Hello everybody, welcome to the week 2 recording for VB.NET programming. And you can see that week 2 goes from August 19th through 23rd. And I'll close that just to see where we are with all of our announcements. So here are the announcements, and that's where I always have the weekly work listed. I also have, of course, as a reminder, an announcement on downloading the course software. We're going to use Visual Basic 2010 Express. And I have a video posted. It's in the syllabus on how to download that software. Welcome to and getting started. Hopefully you've looked at that already. Index of lesson recordings. This is where I list all the recordings. And finally, week 1, if you haven't completed that, go get week 1 work done. And speaking of week 1, I'm really happy with most of the work that's come in. I have lots of students that are in the 90s on their grade percent, and they maybe just have a couple of things they need to fix on one of the write-ups to get to 100%. Out of my 20 or so students, I have a handful of students who are at 100% on the work for last week, so keep up the great work. I really appreciate that. So week 2. Week 2, we're getting into the software development and architecture unit, and we're only doing the first 3 parts. We're doing the introduction section, sections A and B only. I spread this unit out amongst 2 weeks to get us off to a little bit of a slower start in case we have students registering late. Also just allow you to slowly get into the swing of things. So I'll see you on Tuesday. Of course, you're watching the lesson recording. Well, you're doing that now. Complete the write-up for the week. And a reminder, attend the live Class Connect session. And then we're getting into the unit. You're going to study the introduction part. The discussions, we're skipping all the discussions in the class because what I've done is I've integrated, in some cases, the discussions into part of the write-up. So don't worry about doing the discussions. And I can't take them out of the course. I can only take them out of the grade book. Then you're going to look at section A, which is about systems development lifecycle. The quiz, you have to do the quiz preview first, of course. Then section B you're going to do. Another discussion on Thursday to skip. Then on Thursday there's the alternative to SDLC quiz, so do that. And the research other alternatives assignment. So this week you're going to turn in the write-up. So that's one thing you'll submit for your work. SDLC quiz, that's 2 things. The SDLC quiz, I need to see, maybe I have that thing listed twice. Let's go down here. Actually, you have the the alternatives to, no, you don't have that. Yeah, you do the alternatives to SDLC quiz. So that's what, yeah, this one right here. So you have that quiz and then the research assignments. You have 4 things you're turning in this week. All right, well, let's go ahead and jump into week 2. So software development architecture. Oh, before we do this, one thing I want to show is for this unit, there are 4 quizzes. Here are all of the quiz previews. So I've done the quiz previews all together. So there's the SDLC quiz. Here's the alternatives to SDLC quiz. So since they're all pretty short, I went ahead and just made them all one thing. Make it easier for you. All right, so now we're into software development and architecture. And of course, before I get into the units, I always want to look at the write-ups so we can make sure we answer the questions. And of course, on the write-ups, remember, you're going to copy and paste everything into the word processor. So you'll copy all of this and put it into a word processor program. Then have that word processor open as you watch this recording. When you see an answer, pause the recording and then type the answer below each of the individual questions. When you finish, check your spelling and grammar. And I would suggest you save this file. So just save this as week 2 write-up. That way, if you have to go back to it later on, you have it. And then after you have that done, then of course you copy and paste all the questions and answers and question numbers into the Dropbox and do not attach a file. So I have you save it just in case your computer, I mean, you should actually save it if we're working the right way. You would save it as you work along, just in case the power goes out or something like that. So again, as you work to save this, just call it week 2 write-up. Then you'll know exactly what it is. It'll be easy to find. Okay, so there's the write-up. So introduction. What do you call the process of developing software and what is its abbreviation? So let's go into this section. So here we are, software architecture, development and architecture. Do you know how a new product is developed and the steps involved in the process? Well, a new product undergoes many changes. So this would be like, if a new Coca-Cola or new soft drink or energy drink is developed. It goes through planning, analyzing, designing, and testing. And then that goes back and they maybe analyze and design a little bit more. Well, that's what software does too. Now, software, the process is called software development life cycle or systems development life cycle. And the abbreviation is SDLA. So that's the process of getting software developed. And it's the same process is used to create a program. So that's why they bring this up. So in this class, you're going to be using the SDLC, Software Development Lifecycle, or System Development Lifecycle, to create programs. Now in this whole unit, in the SDA unit, we're going to look at how to identify software development life cycles, phases, and definitions, 3 alternatives to traditional models, at least 1 alternative to the SDLC traditional waterfall model, advantages and disadvantages of different models. We're going to look at creating a flow chart, and then look at single and n-tier architectures. Now those will be later on, like 4, 5, and 6. Those are going to be in later sections, because again, we're doing just sections B and A and B of this unit. And that's going to cover like these 3 things. Graded assignments, don't worry about looking at this. Always just look at the grade book. The grade book will tell you what you're getting graded on. And discussion, we're skipping the discussions. But this talks about processes and planning and things like that. And sometimes I integrate the discussions into the write-up, so don't worry about that. Okay, so we did the introduction section, and we answered that one class connect write-up question. So now we're going to get into section A. And section A is all about the systems development lifecycle or software development lifecycle. So let's look at the write-up. So the 5 steps in the software systems development lifecycle. Why does the waterfall method have that name? What is the main purpose of the design phase? What is the purpose of the maintenance phase? So I want to keep those things in mind. So here we are in section A. In section A, in systems or software development lifecycle, here are the 5 steps. So first, you want to gather the requirements and analyze the needs. So that's done all at the same time. The second step is you do your design phase. Then you do your coding phase. Then you test the coding, and then you maintain it. Now, oftentimes testing goes back into coding or even back into design, and it starts over. And then maintenance is after the program is actually, out there working. But these are the 5 steps in SDLC. Now in this unit, or in this section talking about SDLC, we're going to explain how the SDLC is helpful in creating software and explain the different phases in SDLC. So the software development or systems development lifecycle. We talked about what it does and that there are different models that are used, but there's really one main model, and we'll learn about that shortly. And the model is a series of steps to guide the person working on the program. So you do everything in the right order, and then the program, then everybody knows what phase the program's in, and then know what the next steps are and things like that. Now here you can click to play, and what this avatar does is she actually reads this stuff down below, reads this whole thing. So I'm not going to click on that for you, but you can if you want to. So waterfall method, it's the classic style, or it's the main style that's used. And it has these 5 steps. We've kind of talked about these before, didn't we? And the thing about the waterfall method, reason it's called that is that each step is completed before the next one. So that's why it's called the waterfall method. So just like if we're looking at water flowing, water has to flow out of this level. Maybe these were like 5 rocks, right, or 5 pools for a waterfall. Where water has to flow out of this one in order to fill up this one, then that flows out to fill up this one. So that's how the waterfall method works. And that's why it's called that, is because each step has to be completed before the next one is started. Now there are variations, and sometimes you can have steps between testing and maintenance and things like that, but in general this type of method is followed. So you can see the 5 different parts of the waterfall method. And it's been around for a long time, since 1970s. And again, each step after the first one flows in logical order. So this is really the best answer. It's called the waterfall method because each step after the first one flows down a logical order. And so each step is logical and sequential. So sequential means going in order, like the numbers 1, 2, 3, 4, those are sequential. Well, these 5 steps are steps 1, 2, 3, 4, 5, right? Now, some developers don't like to use this because it requires to do their work in specific order. Also, it says it's not a good model to use if the customer or end users do not know their requirements, or they have to change their requirements halfway through. So there are different methods that are put in place of waterfall, but waterfall is it's kind of the building blocks for the structure of how all software and programs are made, even though it can be changed a little bit. Now this is talking about the planning process. In the planning process, it talks about, like, what do you think about when you decide to go on a trip? Well, if you decide to get ready to go on a trip, you have to plan certain things, right? You plan the starting dates, the places to visit, the things to do. So what they're just getting you to think about something in your life, like planning something, and how that could work into software, how planning is an important part of software. So software developers, they analyze the project before they get started. They need to, the final goal of it needs to be understood and figured out before they start into the process. So they have the goal in place, and sometimes they work backward and then get into that first phase and then start working on it. And of course, when they start looking at the goals, they have to think can they overcome any potential problems and things like that. So the planning process is all about knowing where you want to go and then figuring out the steps to get there. Requirements, so gathering requirements, gathering information. So just like if you're going on a trip, you might want to gather information about tourist spots or places you would stay and things like that. Well, same with programming. You need to gather different pieces of information and data in order to start working on your program. And what they do sometimes is they prepare a document that talks about the different functions and features of the software, and that's called the software requirement specification. So imagine this, they're planning a program, and if they get the requirements in a document of what they're supposed to do, then they will know exactly what steps they need in order to develop that software. And they will understand the issues that the program needs to address and the problems that the software will solve. So you can see how after the planning part, how you start gathering the requirements, and that can really help you move ahead. The design, so the design phase, so just like in going on a trip, you have to decide your itinerary, where you want to go. Well, same with the design phase. The design phase is deciding where you want the program to go. So in the design phase, developers decide the components or elements of the software, the different pieces that go into it, right? That's the important part of the design phase. So they have to decide what elements are included in the program. And you can see they have different layers that they have to go through. And sometimes you can the design phase can be shown in this flow chart. So you complete the presentation layer, then the logic layer, then the data layer, and then you have your database that you create. But really in design, they have to decide which elements they have to include in the program. So I'm going to go back to the write-up to see what is the main purpose of the design phase. Okay, we just mentioned that, didn't we? Main purpose of the design phase is to decide what elements to include in the program. Main purpose of the design phase. Then you get into coding and testing. So of course, as you start to do your coding, this is going to get you from the design phase, getting closer to your goal of having the program do what you want. And most times programs start the process of writing commands only after the requirements and design are complete. Because if you don't know where you're going to go with your program and how you're going to get there, how can you start doing the coding? So the coding is what makes the program run. And of course, not all programs are perfect right off the bat, so you're going to have the testing phase eventually. So coding and testing, they sort of go together because you test the coding as you go along, then you go back and adjust your coding. You don't just do the whole program, then decide that the first little piece of coding was wrong. So coding and testing kind of go hand in hand. Then finally, the maintenance stage. The maintenance stage is where changes and corrections have to take place. So, some examples like customers might change their mind of what they want the program to do. So the maintenance phase, the programs go through the first 4 phases to add enhancements or make changes. These are the main 2 things. So the programmers add enhancements or make changes. So what that means by adding enhancements is to make the program better, or maybe new features that they didn't think of before, and then to make different changes. So those are the 2 things that are done during the maintenance phase. Here's a little bit about the waterfall method. So you just work through this, just hit start and work through this to see what you understand about the waterfall method. And the SDLC quiz, remember, always do the quiz preview first. So right over here, all the quiz previews, here's the SDLC quiz preview. Just make sure you understand that. All right, the Class Connect write-up. So we answered all of these, didn't we? We sure did. So now, Section B, the alternatives to waterfall. In prototyping, how does the customer get involved? What are the 2 advantages of the RAD method? In object-oriented programming, how are object and class related? Using a car as an object, list 3 attributes of that object. Okay, Section B, here we go. Now in Section B, there are alternatives to SDLC, or alternatives to the waterfall method. And some of those, there's software prototyping, rapid application development, and object-oriented models. Those are the 3 alternatives to SDLC, or alternatives to the waterfall method. So in this section, we're going to understand software prototyping, understand RAD, and then describe object-oriented model and learn about that. So software prototyping. The coding takes place once the requirements and design phase are complete. The customer then tests the software and gives the developer comments. So the customer gets involved in prototyping by testing as it goes along and gives comments. Remember, in the waterfall method, the coders, the programmers tested it. But in this case, the programmers in software prototyping, the programmers would send the prototype of the software to the customer, let the customer test it, then the customer gives their comments. So this is how the customer gets involved in prototyping. This is kind of neat because then the customer can make changes that they maybe never thought of. And this might occur several times. The customer might test it. So you can see how software prototyping gets right in the middle of this 5-phase process. Software prototyping goes right in here. And of course, a prototype is a sample or a model of the real thing. And you can see that prototyping is getting to be much more popular because it's very difficult to gather all the customer's requirements right at the beginning. So then the customer can give different requirements as it goes along. Alternatives to SDLC, so now we're looking at RAD, or Rapid Application Development. And this is designed because programmers felt that waterfall method was really slow, that it wasn't a speedy process. So in RAD, you can see what they do is right in the design and coding phase, they demonstrate it, refine it, and build it. So it's similar to the previous one where we talk about prototyping. But here there's a lot more testing that goes early on, then they get into the main testing later on. So it uses the same phases, but there are multiple reviews of the software before it is completed. Now, 2 advantages of RAD is the programmer can reuse previously developed software, and they can put off the designing and coding advanced features. So in RAD, they might create one part of the program and then start on the next part of the program and say, hey, I could use some of those features from my first part of the program to develop the second part of the program. So that's why it's called Rapid Application Development. It's much faster development of code is the idea behind RAD. So again, here are the two advantages to RAD. Alternatives, another alternative is object-oriented. And object-oriented is when you think of an object that is part of the program, and then you design around that object. And object-oriented is what Visual Basic is, so you really need to understand this. So you have an object and you have a class. So a collection of objects is called a class. So if we had a bunch of cars, like I go out to the parking lot at the mall, and I have a bunch of cars there, those are objects, and then the class would be cars. Now this may not make sense early on, but object-oriented program is built around objects and classes. So think about that. Objects are individual items, then classes is the whole thing. Like all of you students, you're all objects, but then you are all part of my class of students. So we need to think about that, because in object-oriented programming, you can reuse objects to make life easier as you do your programming. So the relationship between objects and class is that an object is a single thing within a class of similar things. So an object is a single thing within a class of similar things. Here's a little tutorial that talks about object and class. You can listen to it. You can also click here and you get a copy of the transcript that talks about it. So object-oriented programming uses classes and objects to design computer programs. So a class is a blueprint to create objects. So for instance, all of us as humans, we all are created off of a blueprint. The general blueprint is that you'll have a head, 2 arms, 2 legs, and a body, right? That's the blueprint. But we all are different objects within that blueprint, and we all have different attributes. Like I have brown hair, well now it's mostly gray, then I have blue eyes. Those are attributes for my object. Others of you might have blonde hair, brown eyes, so those are your attributes. So if we think about a car as an object, or the class of cars, we think about the class of cars have different attributes. Those are like different properties. So some of the attributes of a car, the features of different cars might be that they might have different colors, might be different sizes, might be different makes. So those are the attributes of the car that make them a different object from other cars. So this is going to be an important thing for you to think about, is that the class is the giant thing. So we have a class of cars, but then each individual car has its own attributes, like these different features of a car, and then that makes those cars different objects within that class of cars. Now you'll also learn a little bit more about modules. Like modules is a subpart of a program or a little piece of a program. So if you're thinking about a car, you have to have the engine, the tires, etc. Those might be modules or different pieces of the car, just as a module is a piece of a program. Modularity means where you can take different pieces and put them together to form your main object. And then we're also going to learn in object-oriented programming, we're going to learn about things that are called different functions, or different activities of an object. And polymorphism, poly means many, morphism is changes, so different changing components of an object. And if you look down here, in object-oriented programming, we can create indefinite numbers of objects. So just think about this. If we talk about a car as a class, and if we want to talk about the size of a car, the color of a car, and the make of the car, you can think of hundreds of different cars, can't you? So if we think about a blue Chevy, Corvette, then a red Chevy Corvette, then a purple Chevy Corvette. Right now we've given 3 attributes or we've come up with 3 different objects for that class of car, haven't we? Or if we think about people, if I had all 30 of my students in one room, we all have different attributes, so we would have 30 different objects in that class of people. So it's really important for you to think about the difference between class and objects and how they're related. And again, a class is the overall grouping, and then objects are different pieces within that class that have different attributes. And this is a discussion on models. Don't worry about that. We have the waterfall model, software prototyping, etc. The alternatives to SDLC quiz, so of course that's right over here, and the quiz previews right here. All the quiz previews are there. I talked about that already. And then research. Now you have this assignment. This is a big assignment. So it's your turn to do a little research on software development life cycles. You learn about waterfall method and other alternatives. So in this one, you're going to create a slideshow that outlines software development lifecycle. Now you can use PowerPoint, you can use SlideShare, or any other type of program. But I want this to be a presentation of some sort. And make sure you include the information about each step of the process, how it's different from the one. So if I was doing a PowerPoint on, let's say waterfall, though you won't be doing that. So in my waterfall PowerPoint, I would have my first slide would be the waterfall method. And I might have all 5 of the phases listed. Then I'd have 5 slides, 1 slide for each phase, talking about each phase, right? And then at the end, I would have my bibliography slide. So again, waterfall method has 5 steps, so I would end up probably with about 6 slides, or maybe 7 slides. So do this appropriately, please. Now this says in the notes section of your slide, write a script to explain the content of the slide. Don't worry about that. What I just want is that the slides just summarize the key points of different parts of the method that you choose. And make sure you include images on each of your slides. The final slide is going to have your bibliography. That's going to be the resources you use. You could click right here, how to cite your sources. Remember, citing your sources tells me where you got the source from, the day you got the source, the day you used it, etc. And I would like you to use at least 3 different resources for your presentation. So make sure you do this well. And to look at the writing rubric, you can go to the orientation section of the course. That's going to be right over here under orientation, and you can go learn about the 6+1 writing, the rubric of how I'm going to grade it. But anyway, what I want is a presentation that demonstrates your model and shows me that you understand the 5, 6, or 7 steps in your model. And again, you're going to have a title slide, then you're going to have slides for each of the 5, 6, or 7 parts of your model, then you'll have the bibliography slide. And do this well and you get an easy 40 points. Now the other thing to remember is that a PowerPoint is not a bunch of sentences on a slide. They're just bullet points, which means like 5 or 6 words that explain something. So I don't want to read a bunch of sentences in your slides. Your slides will just have points, so I can go through it quickly. And then you'll save this, and I would save this as research other alternatives. I'd probably call this, so I know exactly where it goes, I'd call it SDA Unit, research other alternatives. That's what I would save my slideshow as. SDA Unit, research other alternatives, then I know exactly what it's called. And then you submit it in the Dropbox. So that's the work for the week. Let's go back to the write-up, make sure we answered all those questions. Waterfall method, prototyping, we talked about that. 2 advantages of RAD, object-oriented program, how are objects and classes related. Using a car as an object, list 3 attributes of that object. We did cover all those things. Fantastic. So let's go to course home. So again, week 2, here we are. So you're going to do your presentation. And I'm going to go ahead and add something on here on what to save this as. so you'll know exactly what to save it as. But thank you everybody for coming to this. It took about a half an hour. Now you'll get all your work done, and I look forward to work coming in this week. Bye everyone.